have the pleasure to moderate this session. We're going to listen to the 3 speakers in a row, and then we'll collect the questions to the end. So I hope you will be patient and save your questions for the final part, where we'll have a discussion with the online people and the people present. So our first speaker is our colleague, Hélène Ollivier. She's research fellow with the CERES and a professor here at Paris School of Economics. So the floor is yours, Hélène, for 20 minutes. Thank you.
Hi, everyone. So I'm very happy to start. I will start with a quite simple question, and it is carbon pricing bad for competitiveness? So as you can see, I'm an economist, and I want to try to give you a little bit of insight on the EU ETS. Okay. So to answer this question, first we can think about, intuitively, how do we imagine the effects of carbon pricing would be. So the first thing is that carbon pricing should potentially increase the costs for firms that are regulated, either because these firms need to invest in new technologies to abate their emissions, to reduce them, or maybe they need to purchase emission allowances in order to cover the emissions that they have, especially in the context of the EU ETS. Sometimes these allowances are given for free, but there is still a margin, and maybe if the firm emits more, then they would have to still buy some allowances. So those are clear costs. There are also transaction costs, so you need to interact with the market, and you need to potentially, find ways to buy these allowances. There are costs for monitoring the emissions, reporting, etc. And I think everyone has in mind that because of all these costs, there should potentially be a loss in competitiveness. I think this is quite a present thing in the public debate. People think that carbon pricing are potentially hurting firms or maybe hurting jobs. I think this is a kind of a very intuitive thing to consider. But what I want to say today is that there might be another way of looking at this issue, and maybe it is possible that environmental policies could also have a positive effect on competitiveness. And there might be different reasons for that. So first, the firms that are very efficient in terms of their energy use, maybe they receive some allowances for free, and they are able to sell the surplus that they don't really need. Okay? So that's one benefit. Another is a situation where a firm would receive allowances for free and would still pass on to their consumers some increase in the cost, maybe thinking that the cost will increase in the future, so they need to pass this on to the consumers. And in this case, we call that maybe a windfall profit, because they're kind of winning on 2 dimensions. And the third assumption, it's an hypothesis that was developed by Porter. It's the idea that maybe a firm is not exactly forward-looking, and maybe it is not investing in the right technologies, and maybe the environmental policy can somehow push them to make some investment that would then, down the line, make them more productive, reduce their emission intensity, and make them more profitable and potentially more competitive. Okay? So I want you to start with this kind of question. We don't really know the answer, and what I want to do today is go to the data. We have now 15 years of information on carbon pricing in the EU, and as a researcher, I want to collect this data and somehow analyze it. The kind of framework that I'm using is called ex post analysis. What does it mean? It just means that I want to observe firms both before the implementation of carbon pricing was in place and then after, and compare them with similar firms and see how the outcomes of these similar firms diverge because of carbon pricing. Okay? So that's the reasoning, and this is what I'm going to do today. And the kind of outcome that I'm interested in are mostly for manufacturing plants. I'm not going to talk about electric suppliers because in this sector, almost all firms are regulated. So I'm just looking at manufacturing plants. And I want to study their CO2 emissions, CO2 emission intensity, innovation, and competitiveness. Roughly, to give you a broad idea, the literature tends to say that there might be a decrease in CO2 emissions from regulated plants. The impact on emission intensity is very unclear. There is an increase in innovation. And for competitiveness, there might be an increase. This was quite surprising to me. And I thought, well, is this really possible? And I decided to dig into this issue. Okay? The question that I'm asking in the project, and I will tell you a bit more later, is relatively methodological. But I think I can try to give you the intuition in a quite simple way. So what I want to know is if the tools that we are using in order to analyze this problem are the right one. And I'm asking if the methodology is really adapted to the question. The kind of problem that I have identified is the fact that, you know, if you hurt a firm, it makes its competitors somehow better off. Why? Because those firms compete against each other. Okay? And there are these, what we call spillovers. So we can't really say that the impact on one set of firms has absolutely no effect on another group of firms. And this is what I want to try to put into the story. So let's see. This is a graph, and it represents the level of emissions, and here time. I have regulation starting here. So before regulation, basically two groups were trending similarly. Imagine, you know, last year we learned a lot about vaccine trial. So I'm kind of considering that everyone knows how you run a trial. You know, you define a control group, you define a treatment group, and then you look at the outcomes. So this is very similar. Regulated firms are not chosen by the researcher. They are chosen by the regulator. But the researcher can decide what to put in the group of the control firm. They usually choose firms with very similar characteristics to the ones that are regulated. Okay? And what we want to see is if, when the policy is put in place, there would be a break in the evolution of emission for regulated firms. Okay? The way we want to measure the impact of the regulation, what we do is that we assume this control group can serve as a comparison point. Okay? And what we do is that we compare the outcomes between the control group and the regulated firm. We subtract from this difference the original difference that already existed before the regulation. It's called difference in differences for the technicalities. And what we get from that is an estimated effect of the regulation. It's this blue arrow. Okay? And we say all the impact is affecting regulated firms, and look, they are really diverging and reducing their emissions. Okay? What I want to say is that if the break is not only here, but it's also here, and somehow if you hurt some firms, you will make its competitors better off. So if you reduce production and therefore emission for regulated firms, maybe the competitors, they can increase their production and increase their emission as well. And this is represented here with a slight break, not very much, but it exists. Okay? What I want to do is disentangle the effect on the regulated firm and on the control firm. Okay? And in order to do that, I cannot really use this blue line. I need to do this red line. And what I want to show you is that this is what the standard methodology measures, but in reality, it hides two parts. The red arrow is really the true effect on regulated firm, and the difference between the two is the indirect effect on the control firms. And I want to develop a method that allows me to disentangle these two pieces. Okay? So that's the goal. It's co-authored with Jeffrey Barrows, Raphael Carlel, and Martin Gegard. we developed this method, we test it on simulated data, and then we look at French data. Now, giving you a little bit of detail on the EU ETS, I'm sure you all know roughly how it works, but it's a cap and trade mechanism, which means that the firm needs to surrender an allowance for each ton of CO2 emitted. And what is interesting is that usually within an industry, there will be a threshold. So if your combustion installation has a big capacity, so here higher than 20 megawatts, then you're regulated. But if it is just below, you're not. Okay? So quite similar firms can end up being regulated or not. And therefore, we can compare them. And another thing to know is that there are 3 phases. And the first 2, 2005, 2008, and 2008, 2012, were less stringent because they were quite decentralized. A lot of permits were given for free. And it's only in 2012 that the stringency of the policy became a bit stronger. Okay, so this is a quick review of the literature. All of these papers use the same method, the one that I described initially, which is called difference in difference with matching. Okay. And you see here for emissions that, well, maybe there is a reduction in emission, a little bit, but some noise. Here, 0 effect, and here, not very robust effect. So yes, a tendency toward a reduction in emissions, but not completely, like not a lot of strong evidence. And then for the effect on competitiveness, we find either some 0 effect here in the context of French manufacturing plants, or here for Lithuania, and sometimes positive effects here for Norway, and also for this big investigation combining basically all the EU countries, where they find that ETS increased revenues. So when I saw this literature, I was very surprised because I would not really have guessed that the ETS would have really positive effect on revenues and competitiveness. So what we did is that we started with kind of a simulated data where we create a fake economy, we create fake firms, and because we control all the parameters, we can really test if the method is able to recover these parameters. Okay? So this is called simulations. And what do we learn? What we learn is that if you assume that firms compete within an industry, then you end up with the standard method being always giving you an overestimate for revenues. So if it's a positive effect, it will be much stronger than what you observe in reality. If it's a negative effect, it will be also stronger, but in a negative sign. If you correct a little bit with something that is quite ad hoc, it's better, but it's still biased. And what is interesting is that for emissions, you cannot even sign the effect of the bias. And by that I mean that sometimes you will say, oh, emissions were reduced, but in reality they increased. This is how bad the method is really able to handle this potential competition between firms. And we tested and we thought that our method was much better at recovering the estimates under some circumstances. Okay, so now moving to the data. We have the universe of manufacturing firms, and we observe them over a long period of time. We have balance sheet information, so it's sales, number of workers, capital, investments. And then at the plant level, we know the number of workers, and using an energy survey, we can compute CO2 emissions. Okay, so that's the kind of data that is both at the plant level and at the firm level. This is the kind of the broad number of regulated plant and regulated firm. Observe that there is more plants that are regulated than firms. It means that some firms have several plants that are regulated. This is a very interesting graph, at least for me, because it shows the distribution of plants according to their CO2 emissions in 2004. So those plants here are relatively clean. They don't emit a lot. In the medium range, they emit a medium amount, and this is most of the distribution. observe that the regulation status of these plants is 0. So the regulation just targets the most polluting plant. Okay, that's good news, because this is what we want, right? But what we observe is that the regulation share never reaches 100%. We are roughly around 50%, 60%. What does it mean? It means that if you pollute the same amount, you have only a 50% chance to be regulated. Okay? Some firms polluting this amount will be regulated, and others polluting the exact same amount in 2004 will not be regulated. And this is what we use for the analysis. Basically, I'm going just to focus on these firms, and I will study their outcomes after the regulation. Okay? This is another graph that is interesting, which says that now, not at the level of plant, but at the level of firms, what we see is that the firm in an industry that have the highest probability to be under regulation is always the biggest firm. Okay? And then the second firm that have the largest likelihood to be regulated would be the second largest firm. Okay? And this kind of ranking is observed all over time. And on average, we have only 3 firms that are regulated within an industry, which is quite little, but they are responsible for roughly 20 or 30% of the market within an industry. So they are big. And now I move, try to go faster, but I move quickly to the standard results. So this is the standard method. And as you see, if I was putting all my firms, there would be a problem. Why? Because the ones that are going to be regulated, they are quite different from the rest. They are trending up in terms of sales before the regulation is in place. So the regulation starts here. So this is not good. What I need to do is I need to restrict the group of control firms to the ones that have similar characteristics to the regulated firm. And here you see that now in the pre-period they are very similar, but after the regulation, the firms that are regulated are growing more. Okay? So for competitiveness, there is no loss, right? But this is a naive kind of method. And my idea is that maybe this is an overestimate. And we need to control for indirect effects. This is what we do here in a relatively simple way. And we do see indeed that the direct effect is positive, as was shown previously, but the spillover effect is negative. So yes, there is this tension. Like if you make some firms better off, others will potentially suffer. And just comparing the two give you an overestimate of the true impact of the regulation. So this is a correction that we run for each of the sector, and you see that so those dots are with the corrected methodology, and the diamond is with the original kind of standard methodology. And you see that starting from this, which is quite high, you observe very different effects and maybe much lower effect if you do this correction. Okay, and now the last thing I want to say is that so far I've only talked about spillovers across firms, but what is interesting in the context of EU ETS is that you also have spillovers across plants. Because within a firm, you have several plants, and not all of them are going to be regulated, which means that you only control your emission on, for instance, one plant, but the others, they are not controlled. And what I see, I can show you here, that yes, there is a reduction in emissions in the plants that are regulated, but there is an increase in emissions in the plants that are not regulated, but that are parts of a firm with some other regulated plant. Okay? So somehow emission moves. And with the EU ETS, we think that we are, controlling because we're putting a cap on emissions, but because we have all these spillovers that are not really thought through, we potentially are not really reducing emissions as we think we are. All right, so to conclude, Most of the literature shows that there are emission reduction with little economic cost, but we think that the standard method suffers from a bias. So we build this alternative method and conclude that a priori there is no evidence of a loss in competitiveness because we see quite an increase in sales. And for a reduction in emissions, we observe also some compensation, and maybe there are increases in non-regulated plants. All right, thank you.